Hey guys, today I wanted to showcase for some of those homework problems how to do a change in period to the tangent function. And so I have a really simple tangent function here. I'm going to do two examples, one where I just change the period and one where I do some other changes like amplitude and changes to the midline. And so here's my function. And so as before, we're going to have changes using midline, amplitude, phase shift, and period. Now, as a reminder of those formulas, the midline is based on the value of d, the amplitude is based on the value of a, the phase shift is c over b, and the period is pi over b. Now, this is different. This is one of the big differences between sine and cosine and tangent, is that for sine and cosine, it's 2 pi over b, whereas for tangent, it is just pi over b. So let's look at this function and determine each of these pieces by how they fit together into this program. And so I'm going to use some little colors here. Ooh. Uh-huh. All right, let's do it. So let's do it one at a time. Midline. So in this case, the midline is based upon the value of d. Remember, d is the value that is added on the outside. Since I see no value here, I'm going to assume the midline's value is 0, and therefore this will be on the x-axis, which is common for a lot of these functions, but not all. That's why you have to check. So there's my midline. Beautiful. Now remember, since this is a pretty standard tangent function, I'm going to go count by ones. 1, 2, 3, and -1, -2, -3. And now let's talk about the amplitude. So the amplitude is the number that is a. It is the number being multiplied on the outside. Since there's no number being multiplied on the outside, we assume that value is a 1, which means I'm going to have values going here left to right through 1, 1 above the midline, and -1, 1 below the midline. Remember, it is always about relative to the midline. So if my midline is at 0, I go 1 above it and 1 below it. If my midline was at 5, I'd go 1 above 5 and 1 below 5. Again, it's always based upon the midline. Now we do phase shift. Phase shift indicates the value left to right. And in this case, it's based upon c and b. These are the numbers that are inside our function, which in this case, we have a b value of 2, but a c value we're missing. So in this case, this means my phase shift is 0. And so again, that indicates this function will have its starting value here at 0, 0. So the first thing I should note is that for this function, x and y values, my center value is at 0, 0. Now, let's talk about the period. The period is defined as pi over b. Since I have a b value of 2, this would indicate that my function has value for the period of pi over 2. Now remember, tangent will split this value among the left-hand side of my center point and the right-hand side, which means that my asymptotes will be exactly half this distance away to the left and to the right. So if my dot is here, I go half that distance to the left, which would be negative pi over 4. And again, half that distance to the right, which would be positive pi over 4. This is where my asymptotes are going to be. So again, we take the period's value, which is pi over 2, and split it in half. Half to the left, half to the right, which means my asymptotes are now listed as negative pi over 4 is undefined, and positive pi over 4 is undefined. Again, it's half the period's distance away. So if my period is pi over 2, then my new values would be negative pi over 4 and positive pi over 4, exactly half as much. From there, I take my next two dots, so halfway in between on the amplitude, well, halfway between negative pi over 4 and 0 would take place at pi over 8. So at negative pi over 8, I have a value of -1. And then over here, at positive pi over 8, on the asymptote, I have my next dot, giving me my 3 beautiful dots, and at positive pi over 8, it'd be a +1. Finally, I make this the tangent function, by having this come down here, come through my dot. I level out as I get to the center, boop, and then I continue back up through the dot towards the asymptote right there. And that's how we do it. Notice how the main difference here is between this negative pi over 4 and positive pi over 4, when normally it's between negative pi over 2 and positive pi over 2. That is because our period has been shifted. And to find where the asymptotes are going to be, you take the period and divide it by 2. This will always determine how far to go to where my asymptotes are going to be. So if my period is pi over 2, my asymptotes are at negative pi over 4 and positive pi over 4. All right, let's do this problem again. Now showcasing multiple changes. So this time, let's do a simpler function, something like tangent of 3x on the inside, and let's do 2 changes besides this. So let's do like a 2 tangent of 3x, and then like minus 1. It's going to make this really fun. So I have 3 distinct changes here. A 2 here, a 3 here, and a 1 there. So let's list all what's going to happen here. We have our midline. We have our amplitude. We have our phase shift. And we have our period. Each one is going to do something a little bit different. And so again, these are based upon our values of d, a, c over b, and pi over b. Let's start by drawing my grid. Now I can see this is shifted down 1, which is going to be my first step, is to establish the midline. So my midline is at the value of d, which in this case is a value of negative 1. And so I come down here to negative 1 on the x or y-axis. There's negative 1. And I draw my midline. There it is. So beautiful. My amplitude, I can see I have a 2 out front. So that's where I get my 2 from. My 2 tells me I need to go 2 above and 2 below. 2 above will be a value of positive 1 here on the y-axis. And 2 below would be a value of negative 3 on the y-axis. So I've got my midline here at negative 1. I've got my amplitude there at 2 above the midline and 2 below the midline. So I've taken care of this piece and that piece. Next I do phase shift. Phase shift is based on the c over b value. Since I have no value for c, again, this indicates my phase shift is a value of 0, indicating I can draw my first dot here on the midline on the phase shift. There it is. Last thing I want to do is determine my period. My period is defined as pi over b. In this case, my b value is 3, so this will be pi over 3. Now remember, the period is how long it takes to complete one cycle. So up above, this distance is pi over 2. But notice the values of the asymptotes are not pi over 2, they're pi over 4 and negative pi over 4. The distance between them is the period. The asymptotes are found at an augmented value halfway around this number. So if I have pi over 2, my period is pi over 2. If my asymptotes would then be at negative pi over 4 and positive pi over 4. So if my period is pi over 3, then what's going to happen is my asymptotes are going to be taking place at pi over 3 over 2. So this would be pi over 6. So over here at negative pi over 6, I'm going to have an asymptote. And over here at positive pi over 6, I'm going to have an asymptote. Beautiful. And I start making my table. I'm at an x value of 0, a y value of negative 1 is my center. And then at negative pi over 6, I am undefined. And at positive pi over 6, I am undefined. Again, these are where my asymptotes are. So now let's determine the last values. So halfway in between, so in this case at negative pi over 12, halfway in between, I'd be at the negative asymptote, which is right there. So at negative pi over 12, I'd be at negative 3. And then at positive pi over 12, I would be up here at positive 1. So you can see here I create my three values, again, using the same pieces I have from sine and cosine, the midline, the amplitude, the phase shift, and the period, with an asymptote based upon the period. And I end up with these three values: negative pi over 12, negative 3, 0, negative 1, pi over 12, 1, and then I make it look like a tangent function, going through the dot, slightly leveling off as we get to the center, and then coming back through the dot and up the asymptote, giving me my next function. And so this would indicate to my value that this is in fact the function. Now let's take a look at this with Desmos to verify that it is in fact correct. Okay, here's Desmos. So let's start by looking at this function. So we have 2 tangent of 3x quantity minus 1. So let's point out the easy one to find. Let's zoom in here a little bit. At 0, negative 1, which matches perfectly with my midpoint, I can see I clearly have an asymptote here to the left of it and here to the right of it, but let's verify what that is. My left-hand asymptote is at negative pi over 12. Oh, wait, sorry. It should be at negative pi over 6. I can see that this middle graph does in fact asymptote to this blue line here. It's clearly approaching, but not actually getting there. At negative pi over 12, I should have the point negative 3. So I change this to a 12. There it is. Beautiful. At pi over 12, I have the point 1. That's perfect. And then at pi over 6, I clearly have the other asymptote for this middle period here. It looks beautiful. So again, my red line is clearly being boxed in by these two asymptotes at positive pi over 6 and at negative pi over 6. So there's my two lines boxing it in. I can clearly cross the axis here at negative 1. So there's my two pieces. And then we had those values at there at negative 3 and positive 1 at those very specific fractions. So this looks to be perfect. Yay me. So there we go. There is how to graph a change to the period function using just a basic change, using the asymptotes and the periods. And then a more advanced change where I'm changing multiple components. It just has to do it one step at a time. And notice how we'll always box our piece using midline and amplitude, and then asymptotes, in this case for tangent, are really important. So there we have it. That is it. I hope you guys enjoy the rest of your beautiful Tuesday, and I will hopefully see you guys tomorrow.